Qcharge listeners. Hello again and welcome to today's topic. Today we will elaborate on the article and the news about solid-state EV battery technology, range, improved safety and faster charging. Where's the future of this? How soon? And other concerns are in place. So, what to expect? Well, let us dive into these new emerging technology. In the race towards producing the first electric vehicle with solid-state battery technology, automakers Nissan and Toyota have taken the lead. Solid-state batteries are garnering attention due to their potential to offer more range, improved safety, and faster charging compared to traditional lithium-ion battery. However, there are certain challenges to overcome, such as the availability of pure lithium and the need to build new production facilities. A solid-state electric vehicle battery functions similarly to a lithium-ion battery, but with a significant difference in the electrolyte. Instead of using a gel or liquid electrolyte, solid-state batteries employ a separator that allows ions to flow from the anode to the cathode. This separator eliminates the need for a liquid electrolyte and reduces the flammability associated with lithium-ion batteries. Additionally, solid-state batteries require less lithium and other raw materials, resulting in smaller and more efficient battery packs. The benefits of solid-state electric vehicle batteries are substantial. Firstly, they offer a higher energy density, enabling more energy storage in a smaller space. For instance, an 80 kilowatt-hour solid-state battery could weigh approximately two-thirds less than a conventional lithium-ion battery of the same capacity, thereby reducing the weight of the vehicle and potentially extending its range. This enhanced energy density also contributes to faster charging times. While lithium-ion batteries typically require at least 40 minutes to charge, at a DC fast charging station, solid-state batteries can achieve a full charge in as little as 10 to 15 minutes. Another advantage of solid-state electric vehicle batteries is the reduced fire risk. Lithium-ion battery fires, although rare, are primarily caused by the liquid electrolytes they contain. By eliminating the need for these flammable components, solid-state batteries enhance the safety of electric vehicles. Furthermore, the development of solid-state batteries promotes the improved use of recycled materials. As technology advances, lithium-ion battery recycling becomes more feasible, allowing manufacturers to repurpose end-of-life materials for solid-state batteries. This recycling process helps reduce the environmental impact of battery production by minimizing the need for new mining operations to obtain rare minerals. Nissan and Toyota are actively investing in solid-state battery research and development. Nissan aims to produce affordable electric vehicles without relying on lithium-ion batteries, focusing on all solid-state sodium batteries that are free of lithium and cobalt. This approach could potentially reduce battery pack prices by two-thirds. Toyota, on the other hand, plans to showcase solid-state battery technology in the Lexus LF, potentially debuting as early as 2026. Chinese automaker BYD is also set to release an electric vehicle equipped with a sodium-ion and lithium-ion battery later this year. Despite the promising potential of solid-state batteries, there are obstacles to overcome. The first challenge is the availability of pure lithium, as high-density batteries require significant quantities of this resource. This puts pressure on mining companies and raises concerns about eco-sensitive areas. Research and development engineers estimate that solid-state lithium-ion batteries may require up to 10 times more lithium than current battery technologies. Additionally, the construction methods for solid-state batteries differ from those used for lithium-ion batteries, necessitating the construction of new manufacturing facilities. The process of building these factories takes time, and early adopters of solid-state battery technology may face higher costs associated with establishing these new production sites. However, waiting too long to adopt this technology could result in missed opportunity to capture early customers in the electric vehicle market. In conclusion, solid-state electric vehicle batteries offer a promising future for electric vehicles, with potential benefits such as extended range, enhanced safety, and faster charging times. Despite the challenges related to pure lithium availability and the establishment of new production facilities, automakers are investing in research and development to harness the advantages of this game-changing technology. As the industry moves closer to mass production of solid-state batteries, it is expected that the widespread adoption of this technology will revolutionize the electric vehicle market, leading to more efficient and advanced electric vehicles. I'd like to hear from you, my listeners. What do you think on this matter? How soon will it be? Or will it be at all widely adopted or not? Well, We can wait on new development, or we will do something creative and make progress faster than it is now. We need to start winning in this technological race, or we just might suffer. And that would be all for today's episode, folks. Thank you for tuning in and listening, and stay tuned for more updates and thoughts of people on other topics. Share your stories, articles and thoughts with us, and we will make sure to bring your interest to your convenience of a click. And don't forget to subscribe. Until the next time.